how do we determine how to space those out? And so one of the things that we've talked about in previous lessons is delta x. So delta x represents the distance between the two x values, or the interval length. And we know that that can be calculated by b minus a divided by n. We have that formula. So what we want to do is we want to take that same formula and we want to isolate the n. We want to find out what is n. How many of these values should we have? And so n is going to equal b minus a over delta x. So let's take that, b minus a over delta x, and let's plug that into our formula for n. So we can say that our average function value can be calculated by summing f of x sub k, all of these different y values, from k equals 1 all the way up to n. And then instead of dividing it by n, we can divide it by b minus a over delta x, because that means the same thing. Okay, let's rewrite that just a little bit. So if I'm dividing by a fraction, I can multiply by its reciprocal. So I can also say that the average value of a function can be calculated by taking delta x over b minus a times that summation. Okay, continuing on to rewrite this, I can also take this delta x and multiply it on the other side. Because remember, with multiplication, the order doesn't matter. So I can keep 1 over b minus a on the left side, multiply that by the summation, and then multiply that by delta x. And the reason that we do that is that this piece of our formula, where we're getting all of these y values, and we're adding them all up, and then we're multiplying it by delta x, which is the base value, or the interval length. This is something that we are very familiar with, or hopefully should be very familiar with, based on our work in the last couple of sections. So let me transfer that over here. Next page. Again, our average function value can be calculated by doing 1 over b minus a times the sum of all the y values times delta x. And the thing is that what we want here is a lot of different y values. The more y values that we utilize, the more accurate our average is going to be. So I don't want just a few finite y values. I want every y value that I could possibly use in order to get the average. So as we increase the number of y values, really it's going to head towards infinity, ideally. So what we want here is we want n to go towards infinity, so that we have an infinite number of intervals, or an infinite number of y values resulting. So, in order to get the best average we can possibly get, we need to take 1 over b minus a, and we need to multiply that by the limit as n approaches infinity of the summation. That's okay. All right, so again, we need as many y values as we can possibly get in order to have a really accurate average function value. And so here, if we let n go to infinity, the limit of as n goes to infinity of this sum, then we're going to find the average function value pretty accurately. So to finish this all off, this right here, and I should have included this piece as well, but all of this together is our definition of the definite integral. That's what a definite integral really is. So what I can do is I can use that definite integral notation to represent that sum, the limit of that sum times delta x. So the limit goes from a to b of some function f of x dx. And again, this is the formula that we will actually use because this is the most practical version of everything we looked at. But that's where everything comes from. It comes from adding all of those y values, dividing by how many there are, letting that go to infinity, and then of course this represents dividing by how many there are. Okay, so back to the elevation of that hiking trail, which was given as 60x cubed minus 650x squared plus 1200x plus 4500. So if we really wanted to find the average elevation of this hiking trail, we could calculate that by doing 1 over, I'm sorry, I should have mentioned that the interval was 0 to 5. That's necessary to know. 1 over 5 minus 0, 1 over b minus a, times the integral from 0 to 5 of this cubic function. With respect to x. So obviously this fraction, 1 over 5 minus 0, is just 1/5. So let's calculate this definite integral using the fundamental theorem of calculus. So first of all, we're going to find the antiderivative of the function. And so that antiderivative will be 60x to the 4th over 4 minus 650x cubed over 3 plus 1200x squared over 2 plus 4500x. This time we don't need plus c because it's a definite integral, but in order to use the fundamental theorem of calculus, we do need to now evaluate that over the interval from 0 to 5. So what I'm going to do is I'm going to take my antiderivative and I'm going to plug in 5, and I'm going to take my antiderivative and I'm going to plug in 0, and I'm going to subtract those two to get my final answer. And remember, in order to find the average value of that function, I need to multiply that by 1/5. So using my calculator, I'm going to plug 5 into my antiderivative. Squeeze that in. So I've got 60 over 4. Certainly I can reduce that. But 60 over 4 times 5 to the 4th minus 650 over 3 times 5 cubed plus 1200 over 2 times 5 squared. And again, I can definitely reduce a lot of these, but I'm just going to keep it easy. And so all of that gives me 19,791.67. Now I also need to subtract f of 0, or the antiderivative evaluated at 0. But I can actually see that if I'm plugging 0 into this function, every single piece has an x value, and so every single piece will be 0. So in the end, I end up subtracting 0. Using the fundamental theorem of calculus, this is the resulting area under the curve from 0 to 5. So of course we need to take 1/5 of that because we're not just finding the area under the curve, but we're finding the average function value or the average y value. So let's take that and divide it by 5. And we get approximately 3958.33. And this is feet high. So the trail on average is that high in elevation. Okay, one other quick thing that I want to note for you before we wrap up this section is that you can actually do definite integrals on your calculator as well. Just like you can do summations, you can do definite integrals. So in the same screen, the math menu, you're going to go down to number 9, which is a finite interval. Finite, the same as definite, integral, sorry, not interval, integral, finite integral. And you can see that you have the setup of a definite integral. So let me show you this exact same antiderivative here, or definite integral, from 0 to 5 for 650x cubed. Sorry, that's wrong. 60x cubed. Remember, I want to use the original function, not the antiderivative. The calculator is going to do that part for us. Okay, so 60x cubed minus 650x squared plus 1200x plus 4500. And then don't forget to, whoops, I missed a 0 there. Don't forget to tell the calculator which variable you're integrating with respect to. And in this case, that's going to be x. And so you can see there that I get that same answer that I got when I evaluated the definite integral using the fundamental theorem of calculus. So it's a nice check. You absolutely should know the fundamental theorem of calculus. You won't always be able to use your calculator, especially in future courses. So you do want to know this theorem. It's extremely important, but it's nice to be able to have your calculator to double check. Okay, that'll do it for this section.